Hello, my name is Adeline Richard, and this is my two-way optical communication link project conducted with Maria Tuxbury. So this is my board. As you can see to the right, basically we're looking at my receiver circuit. So with the pink dot indicating that you have the photocell that receives a laser signal, and then the yellow dot that receives my speaker. It basically transmits the sound that it receives. And then you have the left side of my circuit, which is basically my transmitter circuit. And that's basically looking at my mic circuit as well as the aux circuit that I'm looking to do. And then finally, you can see at the bottom, the light indicators that are lit up are basically the indicators for my mic and speaker, actually. And then on the opposite side, those indicator lights are for my speaker. Sorry, the right side is mic and aux cord, and the left side is speaker only. And then according to the key, you can see which circuit is from where. So blue is equal to mic, orange/red is equal to aux, pink is equal to my photocell, and then yellow is equal to my speaker. And so then going into demos. So basically, this is my transmitter. My laser is shooting onto her photocell, and then it's transmitting sound. So this is the working laser with the aux. There's some funky things with the audio, so I'm also going to be playing it on my phone. So I apologize for like the discrepancy in any sound, but this is what it sounds like. Okay. So that was my transmitter circuit. Then looking at my transmitter circuit in terms of my mic, and so that's my laser sending out a signal based on my mic input.
My name is Adeline Richard, and today you will be joining us on
Finally, looking at my transmitter circuit, specifically looking at those indicator lights to show that they work. So when there's a lot of signal sent into that microphone, you can see here back that the lights really light up. So then looking at my receiver circuit, so that's specifically my speaker, I'm receiving signals now, or laser signals from Maria's board. And so I'm directing that onto my photocell with a whiteboard because it's really, really hard to see that laser light and how to direct it.
Okay, and then is it playing? All right, speak. Be a little louder.
and it looks like I'm the queen.
So we were
More
facing some
loud?
audio issues,
The wind is howling like this swirling storm inside.
and
You're
now you
really
can
loud.
hear her microphone. And so finally,
Let it go! Let it go!
there's the speaker
Can't
actually
hold it
transmitting the
back
sound.
anymore!
So it was most audible when she like sings really loudly. Um, but the speaker still did pick up and was able to transmit really soft sound. It was just really hard to hear on camera, which is why I had her speak really loudly. And then this is her receiver circuit. This is basically Maria sending her aux signal from the laser to my own circuit. There are also audio issues with this one. Um, so I'm gonna play a video instead for you for that one as well.
Up, move it up a little bit. Oh, down. Down a little bit. There we go.
Okay, now I put your mic. And so then you can see from here the distance that was actually done and how far we were. We're basically across each other from the lab. And then a little singing intro. But you can hear it here as well.
I think so. My lights are working.
But anyway, moving from this. Sorry, this is a really good part of the presentation that I have here. But basically, moving on to the receiver circuit's indicators, here's a video of the lights working. The receiver itself needs a lot of input in order to be then all the lights to be lit up, and wants that speaker to be really, really loud, which is why I would use my potentiometer to really crank up the signal so that the indicator would light up all the way. Otherwise, it would only light up partially, which is why it doesn't light up all the way here, because when the speaker's really loud, it really hurts your ears, and we were in the lab really late at night. But so here you can see the lights lighting up with the signal that the speaker is receiving and outputting.
Yeah. Okay, now I go to your mic.
So basically, this is my receiver circuit on LT Spice. As you can see, there's the solar cell. You can also see basically the speaker on the other end. Going into further detail. You can see the speaker in the top left corner. And so it's connected to a variety of op amps and then eventually results out. So that amplifies the signal for it. And then at the bottom left corner, you see the solar cell, which is basically actually what is receiving our signal and sending that voltage and that signal to the rest of the circuit. And then finally, you can see the indicator lights that we have on the far right. And so that's basically just all the diodes we needed to indicate the level of signal we were receiving from the circuit. And then here we have my transmitter circuit. Basically, you have the laser in the top right corner, and you have the mic and the aux inputs because they both inputted into basically what is the same op amp, and that transmitted the signal to the laser. Getting a closer look, you have in the top left corner the aux signal, and that's like the sine wave generator right there. That's also labeled aux. The bottom left corner has the mic, which is also another sine generator. And then finally, all the way to that right, you have the laser, which is connected to not only the signals, but then furthermore, or the signal receiver, so aka the mic and the aux cord, which is then threaded through an op amp, and then the laser receives it. But also, that laser also sends signal to the indicators, so the indicators are receiving that signal as well, so they're directly changing levels based on either the mic or the aux input. And so finally, here you can see the actual signal and the voltage that we received. So you can notice that this is an example of one of the voltage sources that was like given when we probed it when we ran the circuit basically. Almost all of them looked like this, so I included just one because every single one was a sine wave. And so here you see in the solar cell, it was a sine wave between -1 to 1 volt. And the speaker was assigned between -2.8 volts to 2.8 volts. Whereas in the transmitter, both the mic and the aux are between 1 volt and -1 volt, but the laser is actually between 3.4 volts to 5.4 volts. So when comparing that to give us a second here. Yeah. So comparing it to the actual voltage values, so unfortunately I wasn't able to get a video due to time constraints. Was recording really last minute and had to leave somewhere the next day. So I wasn't able to go back into the lab to conduct the actual videos. But in terms of the actual voltage values, you can see here that they were actually between the given ranges in the LT Spice circuit. So, for example, the solar cell sign was between -500 millivolts to 500 millivolts. The speaker was between 2.4 and -2.4. The mic was around 340 to 340, -340 to 340. And the laser was between 3.5 volts, actually, sorry, to 4.3 volts. And so, um, all these values are actually sit between the values that were provided with the LT Spice diagram, um, which is pretty cool. Yeah. So thank you so much for listening to my presentation. Again, my name is Adeline Richard, and I presented Project 2 for ECE 2001 with Maria Tuxbury. Thank you so much.